Okay, let me read the question now. Diagram 1 shows the relation of three sets. As you can see here, you have here set P, set Q and set R, and this actually the example of a composite function. In case if you don't know what is this, it is actually a composite function of f and g. Okay, so the question asks us to find gx for the question part A, question B part 1 f square x, whereas for the question B part 2 the function f and x in term of n and x. Okay, so this is the oral question. Okay, so without further ado, let us begin our discussion with the question part A, where we need to find the gx. Okay, it's like this. The question is already give us in a composite function where set P is related with set Q through function f, set Q is related to set R through the function g. Okay, so the first thing what we need to do is we need to write this composite function in terms of mathematical equations. We're going to write it separately, how it's actually related from one to another, from one set to another set. Okay, so let me begin my working. So from here, as you can see here, g in a bracket x plus 2, so g in a bracket x plus 2. Okay, when g in a bracket x plus 2, in this case x plus 2 is your object, so your image in this case will be equals to 3x minus 4. Okay, so this is one of the relation. Okay, and another relation is fx. Okay, fx. Okay, in this case your x is your object. Okay, whereas your image over here will be x plus 2. Okay, so let me highlight for the g x plus 2 equals to 3x minus 4. Okay, this is based on the relation between set Q to set R. Okay, so this is the relation between set Q to set R. Okay, and this fx equals to x plus 2 is obtained through the relation between set P and set Q. Okay, so from here we need to find gx, but then we have a slight problem here. In this equation we don't have gx, but then it is mentioned as g in a bracket x plus 2. Okay, and then it is equals to 3x minus 4. So how are we going to find gx in the first place? So that will be our first problem. Okay, so from here let me write down a general equation that we can use to solve this problem. Okay, so from here, in order for us to find the gx, okay, remember that this is actually a relationship of a composite function. This whole thing is actually a composite function. Okay, so from here we're going to write this g f. Okay, so technically this is the composite function. Okay, because it's begin with f, function f, and then followed by function g. When then I mean when you write in terms of mathematical equation, it will be gf, because you need to solve f first and then followed by a g. Okay, so gf. Okay, and then times with f inverse x. Okay, why a function f times with f inverse x? Remember guys, function and then you times with the f inverse. Whenever you times on its own inverse, you get back the object itself, you get the object x. So this is the relation between the composite function, because this is very important. Okay, I want you to highlight this. Okay, let me box this so that you guys can take it note. Okay, so in this case f times with f inverse x equals to x. So this is the composite function relations. Okay, of original function, and then when it has a composite of its own inverse, you get back the original object. Okay, so let me box the up one. Okay, this is our only way for us to solve. So from here, the step one, what you're going to do is we're going to find f inverse x. Okay, step one, find f inverse x. Okay, this will be our very first step. Okay, so from here let us proceed to solve the question. From here it is a standard inverse question. From here we're going to let f inverse x, okay, it is equals to y. Okay, this inverse we're going to move it to the right hand side, okay, and then it's going to become a function fy, it is equals to x. Okay, so from here in this case function f we're going to substitute with the object y. Okay, instead of x we're going to write as y. So from here y plus 2 it is equals to x. Okay, so from here y will be equals to x minus 2. Okay, this 2 from the left hand side you move it over to the right hand side. Okay, and from here you get your f inverse x is equals to x minus 2. Okay, so this will be your step number 1. So let me underline the solution. Okay, just a straight line. This is not the final answer, guys. This is just one of the step solution. Okay, so this is the first step. Okay, you already get the f inverse now. Okay, once you get the f inverse, now it will be easier for us to solve this. Okay, so from here let us proceed to solve this. Okay, so from here gx is equals to gf f inverse x. Okay, so from here gx is equals to, okay, like I said, okay, remember guys, okay, whenever f the original function, composite function with its own inverse, you get back the original value, right? Okay, so from here, since your f inverse x is equals to x minus 2, so from here gf, okay, in a bracket x minus 2. Okay, so from here gx will be equals to, okay, so in a bracket x minus 2, so and then minus 4. Okay, instead of writing x we're going to write x minus 2. We're going to map the x minus 2 over the function g over here. So from here gx will be equals to 3x minus 6 minus 4. Okay, 3 times with negative 2 and then minus 4, and hence you get your gx is equals to 3x minus 10. Okay, so this is your answer for the question part A. So let me underline the solution. Okay, so we're done with the question part A. So let us focus on the question B part 1. Okay, so for the question B part 1 we are required to find the function f square x. Okay, f square x. Okay, this expression means that the function f being mapped for 2 times, which means that fx. Okay, so from here f, okay, in a bracket, so from here fx, okay, so from here function fx is x plus 2. So from here we're going to map here x plus 2. Okay, and this x plus 2 will be mapped again into the function f. So from here x plus 2, okay, close bracket, plus with 2. Okay, so from here you get your f square x is equals to x plus 4. Okay, so let me underline the solution for the question B part 1. Okay, let us focus our discussion for the question B part 2. Okay, for the question B part 2 they ask us to come up with the general expression f and x. Okay, but in order for us to come up with the general term f and x, we need to come up with another expression right after the f square x, which is f3x. Okay, in this case, okay, f3x, which means that function f is being mapped for 3 times. Basically function f and x, it means that the function fx is being mapped for n number of times. Okay, that's what they're trying to explain to you through this question. In this case will be f, f, fx. So 1, 2, 3. Okay, let us start our first one. So from your first working, f, in this case will be x plus 2. So this x plus 2 will be mapped through the function f for the second time. So from here, f in a bracket, x plus 2 plus 2. Okay, and then equal to f in a bracket, x plus 4. Okay, and then this x plus 4 will be mapped into the function f again. Okay, for the third time, this being mapped for third time, guys. Okay, that's why I'm telling you that you need to be careful in this working. Okay, so this x plus 4 will be mapped into the function f. So from here, x plus 4 close bracket, remember, plus with 2, because your original fx is x plus 2, right? So remember to map this. Okay, you treat the whole thing as x, but instead of writing x, you write x plus 4. Okay, and then you write here plus 2. Okay, from here now you'll get equals to x plus 6. Okay, so let me underline this. Okay, from here we notice actually there is a pattern from one number to another. When the f square x change to f3x, okay, the pattern change from x plus 4 to x plus 6. So every time when you increase the number n by 1, so the n number is increasing by 2 respectively. Okay, from here fx is x plus 2, f square x is x plus 4, and f3x is x plus 6. Okay, let's say if you're doing a calculation for f4x, it will be x plus 8. Okay, when you are mapping the function f for 4 times, you will get x plus 8. So there is a pattern over here. Okay, that pattern from here you already calculate. So every time it's actually increasing by n number of times. So from here, hence function nx will be equals to x plus with 2n. Okay, 2n. So this will be your answer. Okay, every time your n increases, okay, you will get a difference of 2 at the behind, at the coefficient of behind of the 2. So this is your answer, guys, for the question B part 2. So let me underline this. Okay, all right, so let me scroll up. Okay, we have come to the end of our discussion for the Add Maths paper 2 question number 3. Okay, so if you like this video, make sure that you give a thumbs up. If you haven't subscribed to the channel, make sure that you subscribe to the channel and hit the bell icon for more upcoming Add Maths tutorial videos in the future, and make sure that you share this video to your friends. Thank you everyone for your support, and I'll see you in the next video.